So graph 9.7, graph quadratic using transformation. Using transformation. Okay, so this is a little bit wider. Want to see how we can finish, but we might not finish this section 9.7 because it's, I don't know why it's so wide. Okay, so let's start. Now, in this case, what we need to do is actually this is we want to graph this function f of x equals to ax squared plus bx plus c. So we are trying to graph that function f of x. And previously in section 9.6, we did this one by use of the properties. So we use the properties to graph this. Now, in this section, then we want to use a transformation. We want to use a transformation. So we want to see how this graph can be graphed using the transformation. So what we want to start from is so the reference point is when f of x equals to x squared. F of x equals to x squared. So this is actually the reference point where you start from. So where you start from. So in this case, it's either the next transformation will shift upwards, downwards, horizontally. Yeah, so that means either shift vertically or horizontally. So we want to see how when we add a constant k, then what happens when we add this constant k? Again, what we will do is if f of x equals to x squared, what happens when we subtract the constant k, the constant? Okay, and then later on, then we will graph this function f of x equals to what happens when x minus h, and then we square. What happens there? And then what we will also do is what happens when f of x equals x minus h square, and then we add or we subtract the constant. What happens to the graph? And then finally, what we're going to do is f equals to a x minus h square plus or minus k. What happens when there is this constant here? So in real sense, at the end of it, this is of this form, but this one has been simplified by completing squares. This has been simplified by completing squares. Okay, so we will see all those steps. So this is actually the final step. The final step. Now, let's start by if we have the function f of x, we have the function f of x equals to x squared, and f of x, or we can say g of x equals to x squared when we add 2 here, and then let's say g, this one h of x equals to x squared when we subtract 2. So when we add 2 to x squared and when we subtract 2 from x squared, how will that graph be like? How will it be like? Okay, so here, what we need to do is we can make a table. Yeah, and then we can use this one as x, and then we want to get f of x. We want to get x, f of x. We want this g of x. We want to get x, g of x. And then we have this h of x. Then we want to get x, h of x. And then we plot the three polynomials. So we can actually start from -3, -2, -1, 0, 1, 2, 3. We can start from this. Now, in f of x, when x squared is -3, then f of x is what? Right? And then this will be what? -3 and what? And 9. And this one will be what? If f of x is 3, so it will be what? 3 raised to 2 is 9 plus 2 is what? 11. And this one will be -3 and 11. This h of x, when we subtract 2 from 9, you get what? Get? And this will be -3 and 7. Okay? 3 and 7. When x is 2 here, then it means this one is 4. This one is -2 and 4. This will be 4 plus 2 is 6. And this one will be 2 and 6. Then 4 minus 2 is 2. And this one will be -2 and 2. When x is 1, so this is 1, this is -1 and 1. This is 1 plus 2 is 3. This one is -1 and 3. This one is 1 minus 2 is -1. So here is -1 and -1. Okay. We have 0. So this is 0. This will be 0, 0. This will be 2. This will be 0 and 2. This will be -2. And this one is 0 and 2. Okay. The next one is 1. So just similar to the other one. So it will be 1. This will be 1 and 1. This will be 2. This will be 3. And then it will be 1 and 3. This will be so that is 1 minus 2 is -1. And then it will be 1 and -1. The next one is 4. So 2 and 4. Then the next one is 4, 6. So 2 and 6. The next one is 2. And then 2 and 2. Then lastly, in this case, this is 9. And then we have 3 and 9. This is g of x is 11, 3 and 11. And then this is 9 minus 2 is 7. And then 3. So we want to graph them. So we want to graph f of x, g of x, and h of x. So there we now have the gradients. We have their gradients there. Sorry, we have their coordinates. Now, so when we come and graph this, then we put it in this. So the highest is 9. So we put 9. We have 1, 2, 3, 4, 5, 6, 7, 8, and maybe 9. And then for x, the highest is 3. 1, 2, 3, 4, 5. 1, 2. Then here, let's say with 1, with 2, maybe 4, 5. Okay. So now using the first property here, using the first property that we had, how will this be facing? Is it upwards or downwards? Upwards, right? So they will be like this. Now, using these gradients here, then we want to plot the graphs of f of x, g of x, and h of x in this. So let's start from f of x. So these are the coordinates. So we can start from -3 and 9. So -3, and then it goes to what? 9 is somewhere here. Okay. Are you guys seeing that? 3, 9. And then -2 and 4. So -2, and then 4 is somewhere there. Then we have -1 and 1. So -1 and 1 there. And then we come to 0, 0. Then we come to 0, 0, and then 1, 1. So 1, 1 is there. Then we come to 2, 4. 2, 4 is here. And then finally we come to 3, 9. 3, 9. Yeah. So when you plot this, then comes up with so that is, so this is now f of what? F equals to x squared. Now, what happens when you add 2? That means g of x, g of x. So it goes to 11. So we can ignore the one. So okay, we can put it to 11, 10, and then 11. Okay, so 3 and -3 and 11. So -3 and 11 is somewhere there. The next one is -2 and 6. -2 and 6 is somewhere there. The next one is -1 and 3. -1 and then 3 somewhere there. And then 0 and 2. 0 and 2 is here. Okay. And then it comes to 1 and 3. 1 and 3 is here. And then it goes to 2 and 6. 2 and 6 is somewhere there. And then finally 3 and 11. 3 and 11 is somewhere there. Okay. So when you come and load this, come and load this one, then it now comes this way. It comes here, goes there. So it goes like that. Okay. So it goes like that. So this is now when we add x squared plus 2, when we add. Now, what happens when we subtract 2? So it means this h of x, h of x. So we have -3 and 7. So we have -3 and 7 is -3 and 7 is somewhere here. We have -2 and 2, -2 and 2 is somewhere there. We have -1 and 1, so -1 and -1 is somewhere here. And then we have 0 and -2 is somewhere here. Then we have 1 and -1. 1 and -1 is here. And then we have 2 and 2. 2 and 2 is here. And then finally we have 3 and 7. 3 and 7 somewhere. So when we plot this, then it comes. So this is now h of x equals to x squared minus. So what can we see from here? So what can we see from here? So what can we see from here? So it means that this case there is a shifting. There is a shifting of 2 points up, right? When we add, and then there is a shifting of 2 points down when we do what? We subtract. So when we add the constant, then it shifts upwards. When you subtract the constant, which is 2, then it shift 2 points or 2 units downwards. So we can say the graph of f of x equals to x squared plus k shifts the graph of f of x equals to x squared vertically k units. The graph of f of x equals to x squared plus k shifts the graph of f of x equals to x squared vertically k units. So as we can see, when we add, so it means that one, if k is greater than 0, that means it is positive. If k is positive, then it shifts k units. If k is less than 0, then it shifts what? Downwards. How many units? K. So it will shift downwards. K units. K units. Is that clear up to there? Is that clear? Okay. Any question? Now, if we have now the graph f of x, if we have f of x equals to x minus h square, we have this graph there. F of x equals to x minus h square. Then what happens? What happens? What happens? So if our reference point is f of x equals to x squared, then what happens when f of x equals to x, let's say minus 1, and then it's square, and then also f, let's take this one as g of x, and then you take this one as h of x, equals to x plus 1, and then we this one. So let's do the same thing like what we've just done for the other one. So if we take x, and then we take f of x, we take g of x. So we have x, and then f of x. We have the g of x. We have x, g of x, and then h of x. H x, h of x. So if we use the same one, -1, -2, -3, -2, -1, 0, 1, 2, and 3. So previously, what did we get in the first one? We got 9. Here is 4. Here is 1. Here is 0. Here is 1, 4, and 9. Then here we got -3, 9. 2, 4, and 1, 1, 0, 0, 1, 1, 2, 4, and then 3, 9. 3, 9. Now, what happens when we now add? So if x is -3, and then we minus 1, we get what? -3 minus 1 is -4, right? And then you square, we get what? 16. What am I doing here? So this is actually x, and then f of x. Okay, and this one is I confused. Okay, so this is g of x. Okay, and then let's have another one here, x, and then g. Okay, so we got 16 there. So -3 and 16. The next one, -2. -2 minus 1 is -3. Square is 9. So -2 and 9. The next one, -1 minus 1 is 2. 2 plus 2 square is 4. So this is -1 and 4. Next one is 0. 0 minus 1 is 1. So so this is 0 and 1. 1. 1 minus 1 is 0. So 0, 1 and 0. 2. 2 minus 1 is 1. So 1. And then 1, 2, and 1. Then finally, 3 minus 1 is 2. 2 minus 2 square is 4. So this is 4, and then 3 and 4. Next one, h. We add. So minus 3 plus 1 is 2. So you get 4. So minus 3 and 4. The next one is minus 2 plus 1 is 1. So 1. So 2 minus 2 and 1. Minus 1 plus 1 is 0. So 0. And then plus 1 is 0. And then 0. 0 is 1. Then 0 and 1. 1 plus 1 is 2. So 4. And then 1 and 4. And then 2 plus 1 is 9. It is 3. So this is 9. And then 2 and 9. And then 3 plus 1 is 4. 4 square is 16. So we get 3. Now, using the same, we can use the same graph. So we can use the same graph. Yeah. So our reference point is f of x. Now we can take this one as g prime, okay? G prime of x, and then this h prime of x, okay? So let's try to plot this. So we have already plotted this. So let's try plotting this x and then f prime of x and then h prime and then that. So we have -3 and 9. -3 and 9 is, so we have already plotted this, right? So let's plot this one. -3 and 16 is very fast. So -2 and 9. So -2 and then what? 9 is there. Okay. -1 and 4. -1 and 4 is here. Then 0 and 1. 0 and 1 is here. Then we have 1 and 0. 1 and 0 is here. And then 2 and 1. 2 and then 1 is here. And then 3 and 4. 3 and then 4 is okay. So when we come and plot this, then it comes that way. So this way, that way, comes that way, turns there, and then goes that way. Okay, so this is g prime of x, which is equals to x square, x minus 1, and then x minus 1 square. Okay, now let's come to this. -3 and 4. So -3 and 4 is here. We have -2 and 1. -2 and 1. -2 and then 1 is here. Let's say there. Then we have 1 and 0. -1 and 0 is here. And then 0 and 1. 0 and 1 is here. Then we have 1 and 4. 1 and 4 is somewhere there. And then finally 2 and 9. 2 and 9 is. So when we come and dot this, then it comes that way, goes that way. I think it was going this way, the 9 there. Yes. So this is h prime of x, which is equals to x plus 1, and then the square. X plus 1 square. So if we look at this, we can see something here. We can see something here. So we can see something. So it means that if we have this function f of x equals x minus h and then square. Now, if our h here, if this is of formula, looking at this, f of x equals to x minus h. When x minus 1, when we have x minus 1 and then we square. So what does it mean here? It means that this 1 is what? Means this 1, because using this, it means this 1 is positive, right? Right? So if we have this f of x equals to x minus h, it means that our h is what? Is positive, and that positive is what? This 1. Now, when we come to this, if we have this, it means our h is what? Negative 1. It means our h is negative 1. Are we together there? It means our h is negative 1. So therefore, if we have our f of x equals to x minus h and then it's square, then it means that this is a shifting where? Yes, horizontal. Horizontal. It means this one is shifting horizontal, horizontal, horizontal. So therefore, if number 1, if h is greater than 0, that means it is positive. So if this h is positive here, as we can see from our graph here, if this h is positive, then it means it is this g prime. And where was it going to? It was going to the what? To the right, to the right. So it was going to the right. If this h is positive, then this shape parabola horizontally. Sorry, it is, yes, it is shifting to the what? To the right, right? It is shifting horizontally to the right. Now, if number 2, if h is less than 0, means it is negative. Means it is negative. Then it means it is doing what? Shifting to the what? Shift the parabola. Horizontally. 2 in there. Your textbook is so wrong. So go and check your textbook is really so wrong. Yeah, your textbook is very, very wrong. Okay. Now, so we have seen this. So if our h is greater than 0, it means it is positive. Then therefore it is shifting the parabola, and then the other one. Now, if we now have the function f of x equals to x minus h squared, and then we add the constant k, and then we add our constant k. Now, it means we are either shifting to the right or to the left. And then if we add the constant, then we do what? Up and down. So if we add or subtract, then it means we are going up or coming down. You see what happens here? So it is actually transforming from x squared, and then you either go to the left or go to the right, and then you either go up or go down. Okay. So this is what we call now the transformation. So now, if we have this function f of x, so if, for example, let's do an example here. If we have f of x equals to x plus 1 and then square minus 2, f of x equals to x plus 1 and then square and then subtract 2. Now, using transformation, plot this. So what you need to do, so the first step here is you need to look for h and what? This k. Okay. So what is our h? Our h is equals to what? What is our h? 1. Yes. And what is our k?
-2.
Our k is
2.
negative what?
It's 1 or -1?
Our h?
Yes.
Our h is 1.
Was it positive in the equation?
So you remember this formula? We did this. Huh? So this is our formula, okay?
Yep.
Oh, sorry. Our h is -1. Sorry about that. So our h is -1. And then our k is what? Our k is what? -2. Our k is -2. Then how can we plot this? How can we plot this? So in this case, it is like this. So actually, we can take 1 and then 2 and then 3. 1, 1, 2. So what is happening? We now have our so we start from our reference point, which is what? F of what? X, which is this. is coming that way. It's coming that way. So this is our f of x equals to what? X squared. Now, what happens when we have now f, let's take this as g of x equals x plus 1 and then square. Where is this shifting to? Where is this shifting using this? If our h is greater than 0, and our h here is what? Negative what? 1. So where is this shifting to? To the what? To the left. So most of the time, we usually use the shifting horizontally before we use the vertical, before we use the table. So we start from this. So in this case, if our h is less than 0, then this one is shifting to the left. So it is shifting to the left. How many units? How many units? 1 unit. So it is shifting to the left 1 unit. So it means it will be what? Here. The turning point will be here. So therefore, it will just come up. So this is our what? Let's say g of x equals to x plus 1. And then this square. And then using this, if the graph of, if our k, no, wait, yes. If our k is greater than 0, then it shifts k units upwards, right? If it is less than 0, then it goes where? Downwards. So in our case here, our k is what? Negative 2. Where does it go to? How many units? 2 units. So it goes down 2 units. So 1 and then 2. So our final graph will be here. So finally, it will now be. So this is our final graph, f of x equals x plus 1 square minus 2. Is that clear? Is that okay? Any question after that? So that is our transformation. So that is our transformation. Yeah, the time is what remaining is 4 minutes. Now, if you have the function, let's say this function here. Now, let's say this function f of x equals x squared plus 6x plus 5. Then you are told to graph that using transformation. So what you need to do here is you need to write into the form f of x equals to a x minus h, and then you square into that form. Okay. So when we meet next time, we will come and see what happens when you add, when you multiply by a. Is it going to be skinnier or is it going to be wider? But in this case, since you can still go and read in your textbook. Now, to convert this one to this form here, then we use the completing squares. So we have our function f of x equals to x squared plus 6x plus 5. So in this case, what we need to do, we use the completing squares on one side, not since we have the other function there. So we use the completing squares on one side. Now here, when we were doing the completing squares, what did we do to the coefficient of x squared? We made it to be what? 1, right? Then, after making the coefficient of x squared to be 1, then you separate the variables, right? So you put the variables on one side, and then you put the other ones on the other side. So in this case, you do the same thing, but they are on one side. So in this case, since the coefficient of x squared is 1, then it will just be x squared plus 6x brackets, yeah, and then plus what? Plus 5. So if the coefficient of x squared was either 3 or 4, then you need to factor it out, okay? And then you now do the completing squares here. So to do the completing squares here, then you add half the coefficient of what? Half the coefficient of what? Of x, right? Half the coefficient of x here is what? 3. And then you do what? You square. Okay. Now, to make this to come back, to make this one to come back to this, what do you do in this side? You do what? To make this one to come back, to make this one to come back to this. You subtract what?
Yeah.
This
Try the same.
9. Yeah. Okay, you subtract that 9. Now, using the completing squares, so this is f of x equals to this and this one, which will be x plus 3 square, and then plus what? This will be now minus 4. So this has now become this form. Okay, you see that? Oh, times up. Okay, so that is it. So that is how you can do it. That is how you can do it. Okay, so guys, I wish you well. So make sure you when you're home, you try to finish the homework maybe which you have not done. Then you can meet when we come back.